All right, cool. Let's get started. So we'll do the do now first. It's a nice little review on all the ester material we've been talking about. Let me switch to the document camera so you guys can see. What I've given you is an ester, and I wanted you guys to draw it and also figure out what you need component-wise to make an ester. So remember, with these esters, component-wise, you're always thinking about a carboxylic acid and an alcohol and putting those two together to make our esters. The identification for that ester is that O8 ending, so that's what we're looking at, and that indicates to me that's ester as the functional group. What I would do is I would always start off with drawing the functional group for the ester and then placing down the other information, because this is the base foundation for esters. It's also important to know those because they often ask on the organic exam for you to circle the ester functional group for the polymer questions. That's why I want you guys to start off with that. So the next thing to do is then to translate what the two different components mean with the ethyl and the propan O8. So basically with that information, ethyl tells us that there's 2 carbons. The propane tells us that there's 3 carbons. And basically what you need to decide when you're looking at that is which one goes to what side of the organic molecule. So when we're thinking about the general ester functional group, you'd have an R group and an R group, and that's representing the carbon chain. So with that information, we're trying to decide which section has the 2 carbon chain and which section has the 3 carbon chain. So keep in mind that this section here with the double bond comes from the carboxylic acid, whereas the single bonded oxygen comes from the alcohol. We good? So when I think about the name, the first bit that's coming in as a branch, that is coming from the alcohol component, and the second bit with the parent chain is coming from the carboxylic acid component. So what that tells me is that on this side here is where I'm putting the 2 carbon chain, and then on the left-hand side, I'm putting the carboxylic acid part of the chain. Keep in mind that this is a carbon that you're counting, so you're only adding 2 more to get me up to 3. So 1, 2, 3. A lot of people make the mistake of forgetting the carbon with the carbonyl, that double bonded oxygen, and they accidentally add 1 too many carbons. So that's why I want to point it out so you don't accidentally do that. When I think about what I needed to mix together to make that ester, this component here is from the propanic acid. And then the second bit came from ethanol. We good so far? Hopefully this rings a bell and you guys got it. Cool. So the reason why I wanted to talk about esters as our do now is not only because you guys have did a lesson on esters, and that was the last material we covered, but also today we're going to be talking about polymers, and one of the polymers we're going to be talking about is the polyesters. So polyesters is just a repeated of the ester unit. Do you guys want me to open those blinds? It's making quite a lot of noise. It's a compromise between the blinds and the screen. You do it? All right, so comparing addition versus condensation polymerization. So the addition reaction you guys should have learned about last year. Condensation will be new for this year, and the focus for this year on the test will be the condensation polymerization anyway. So keep that in mind when you're studying. Don't spend a lot of time revising the addition polymerization. I just add it so that way you know in reference what we're referring to. And then polymerization, we're talking about polymers, which is just long repeated chains. So I just want to point out some of that vocabulary to you guys. Cool. So we'll start today's lesson off with an addition polymerization notes, just to recap what you guys did last year. Then we'll have a SciPad page for you guys to do that's just on that addition polymerization, just to make sure it's all kind of in your head and you know what you're doing. Then I will do condensation polymerization, and that's the new stuff for this year. It's a little bit more complicated, so I want to make sure you have the foundation with that addition polymers first. There's a crash course video that we'll watch just to kind of summarize everything we've seen, and then you guys can end the lesson with the Mahi Choice. Sound good? All right, cool. So with the success criteria today, we are looking at number 7, which is the identifying polymerization reactions. There's 2 components for this success criteria, and that is the formation, aka how do we make polymers, and then there's the hydrolysis, which is how do we break up polymers. With that hydrolysis, you can do it in acidic or basic conditions, and that's going to influence what the products are. But today, all I want us to focus on is that formation polymerization. So we'll do hydrolysis in our next lesson. Also, with the polymerization, there's going to be 2 examples that they're going to give you for that. The first one that we are doing is esters. So polyesters, a repeat of the ester unit. The second one is going to be on polyamides, which is the repeat of the amide unit. Polyamides you guys have come across before in biology. That is the long kind of amino acid chain that you build together to make proteins. So that's why I like to start with polyesters, because those won't be as familiar. I also think the esters are a little bit easier to understand than the polyamides. So just to kind of recap, polymers are those large repeating units of some monomer. So when we say a monomer, we're just saying an individual kind of component, and we're just repeating it to make a long, long chain. The monomer I like to think about as individual beads, and then the polymer is just stringing those beads to make a necklace, is the analogy I like. Yeah. So with that polymerization process, there's going to be lots of covalent bonds, because that's how those 2 monomers are going to join together. It's basically what we're talking about with those organic molecules coming together. With these polymers, there's natural versions of it, such as starch, wool, and DNA. It's a really great building block. You can also have synthetic polymers, which are things that are man-made and are non-biodegradable. The good example for that one would be the plastics. So, cool. The smallest polymer is about probably 500 repeated monomers. So when we're talking about these polymers, keep in mind they're actually really, really long chains. And I see people like madly writing things down. It is in the booklet of notes, so don't worry if you... Does anyone need a booklet? I have a few left over. Yeah. Yeah, it's all in here, so I was like noticing people writing down furiously. Yeah, I got part 2. Anybody else need part 2? Yeah, part 2. Yeah, I just told my guys like madly hogging the down Yeah. Part 2? Yeah. The lesson being recorded, so. All right. Cool. What else did I want to say about them? You guys learned about this in 2.4 when we talked about intermolecular forces in those linear covalent networks. So those kind of big structures, but with just the chains. Cool. So basically what you have is, actually I have it in the next slide. Cool. So basically what you have with these polymers and things such as plastic is you have these chains, and there's the weak intermolecular forces that hold those various chains together. And then you can very easily melt those plastics and break those intermolecular bonds and have the plastic melt. Yeah, let's not burn plastic, doesn't smell good. All right. So some things to also note with these polymers, depending on what monomer I start with, and depending on the length of that chain, it's going to influence the properties of that polymer. So for example, the longer my polymer gets, the more tangled it will get, and that will mean that there's more intermolecular forces, and the polymers become stronger. You don't need to worry about explaining any of this component about polymers. It's just to give you guys background information to why we use them. Are we good so far? All right. So like I said, there are 2 types of polymers reactions to make them. The first one is addition polymerization, and this is what was covered last year. With that addition polymerization, the monomers need to be alkenes. So the reason why they need to be alkenes is because we're going to break the double bond and join together those monomers. So I need to break the double bond so that way I have space to then bond together the two monomers. And I'll show you guys how to put that together in a moment. So we call this addition polymerization. It's just like an addition reaction that you guys have seen previously with organic chemistry. You break the double bond and you add to the molecule. In this case, you're adding monomers. For this to occur, we need quite a bit actually, a catalyst, high temperatures, lots of pressure. It is quite a bit of work to make these polymers. And these polymers are going to be named after the monomer that creates them. So you reference the monomer and put the word polymer in front of it. So let's look at how we make them and put them all together and chance to practice that material. All right. So here is my first polymer. And in this case, we are going from monomer to polymer. So with these questions, keep in mind that they can ask you to go in either direction. Either you make the polymer or you break the polymer. So you do need to be able to do it in both ways. So when we are dealing with these monomers, what you're trying to keep in mind is, like I said, you have these alkenes. In this case, if I was going to name this alkene, there are two carbons there, and there's a chlorine. So that's chloro. Ethene is the monomer that's making that one up. I'm not specifying where the double bond is because it can only be in one location. With this case, there's only one chlorine. If I put it on carbon number 1 or carbon number 2, it's still on carbon number 1. So I'm not specifying the number of it. When it comes to putting them together, it's really kind of straightforward. You basically remove the double bond and change it to a single bond. And then you're going to be able to join those two together. So when they ask you to draw, I'm just going to erase it so I can show you how to set it up. And in fact, I'll do it with each monomer as a different color. So they often ask you to do a couple of monomers to show 3 repeats or 2 repeats. I'm going to show 3 repeats. So I have C, double bond C, Cl, H, H. That's my first monomer. Here's my second monomer. So I'm drawing 3 monomers, so that way I'm ready to set it up to be repeated units. So are we okay with that so far? So those each are a monomer. Then, in order to put them together, all I need to do is break the double bond. So I'm getting rid of one of those double bonds in each one of those molecules. And by doing that, what I'm going to be able to now do is join together the monomers. Are we okay with that so far? Now, when we are looking at this, the carbons on the end only have 3 bonds, 1, 2, 3, 1, 2, 3. So there's multiple ways you can indicate that that unit is repeating. You could do a little squiggly line that says this is the repeating section. The other thing that I've seen people do is they just kind of do dashed lines and they do square brackets around it. And they write a little N. The other thing I've seen is just dot, dot, dot.
Do you have to like say what you're using to break the bond? Or are you just showing?
You're just showing it. So like I said, it's very unlikely they'll ask an addition polymerization question because that's last year's material. They're more likely to ask you a condensation polymerization. Yeah. But I want to show you guys the addition one to refresh the material, but also just to show you like a more basic one because the condensation one's a little bit more complicated. Yeah. Are we okay with that so far? So that's how I go from monomer to polymer. Read the question because sometimes they'll ask you to do 2 repeated units. Sometimes they might ask you to do 3 repeated units. It really depends on the question. Most likely they'll just ask you to do 2.
Yeah.
All right, can I move it? Okay. So let's go in the other direction. So that is monomer to polymer. Let's look at going the other way. which is polymer to monomer. So we're asking ourselves, how do I break it down and think about what's the component that makes up this polymer? So what you are going to be looking for is a repetition in the sequence. So when I'm looking at this for the repetition, I see that I have, an ethyl branch coming off, a methyl, an ethyl, a methyl, ethyl, methyl, ethyl, methyl, ethyl, methyl. So what that tells me is that this is the repeated unit. Do you see how I got that? You want me to run through it again? Okay?
You're looking for a pattern.
You're looking for a pattern.
Yeah.
So in this case, I notice that I have the ethyl kind of branch coming off and the methyl branch, and so that's the structure that keeps coming back again and again and again.
Yeah.
What you then need to be able to do is take this structure and figure out what the monomer is going to be. Again, really straightforward, don't overcomplicate it. So basically, if I identify this is the monomer, and I break the bond here, and I break the bond here, I'm going to be putting the double bond here. So once I break up my polymer, I'm going to have to add in the double bond.
Yeah.
So if I was to draw it out, we would have C, double bond C, H, CH3, H, and then that's CH2, CH3. The other way you could draw it, actually I might actually move it so that way you can see it a little bit easier. CH2, CH3. Now, when it comes to naming it, remember, you're looking for the longest chain possible. So 1, 2, 3, 4, 5. So keep in mind with these addition polymers that just because we refer to it as ethyl and methyl when we're looking for the repeated pattern, it's obviously not an ethyl and a methyl when it comes to naming it. It's the longest chain. So in this case, what has made this polymer is 1, 2, 3, 4, 5. So that's pent. And 1, 2. So 2 and 3 is where the double bond is. So pent 2-ene is the monomer that makes up that polymer. And if I wanted to name the polymer, I just put the word poly in front of it. Are we okay with that? All right. What questions do you guys have? None? All right. Shall I move it? This is hopefully a refresher. Yeah. Cool. So I just want to show you guys some common polymers. Such as, actually no, I don't think we've looked at any of these in my examples. So for example, this one here is ethene, and if I was going to name it, I just call it polyethene. And there's some description on what we use it for. So depending on what we have in the monomer and the length of that monomer, it's going to influence the property it has. So when you're thinking about plastics, you know how some plastics are really hard and some plastics are soft and moldable. It has to do with what polymer makes it up. And you can actually look at the bottom of a lot of plastic containers and it'll say like 5, 1, 3 to kind of indicate what type of plastic it is, and that's going to influence its recyclability. Yeah, so there's just some examples. Be mindful that some of these guys, when it comes to the name, these names here, like Teflon, is the common name for it. It's not the actual kind of like scientific name for it. All right, cool. Any questions regarding that stuff, or is that all okay? All right, you guys ready to give this a go? All right. So, what I want you guys to work on now before I move on to the condensation polymers is the addition ones, just to kind of recap it. So that's page 215 in your SciPads. If you finished early, feel free to go look at the Mahi Choice from the last lesson and just do some practice on esters. Cool. All right. Yeah.
So with the first one,
Yeah.
can we also name that polymer?
You can. So that one would be. So it'd be polychloro.
Oh,
You just stick poly in front of it.
Oh.
So you don't name it as an alkane, you name it as an alkene.
So it's different with the monomer, like it actually looks the same.
Yes. Because I've seen it pop up last year in the level 2 exam, but I haven't seen it pop up in a level 3 exam. All right, cool. So let's go back to the notes. So this is the new stuff, and this is the stuff that they're going to ask you on the exam, or most likely going to ask you on the exam. And that's all about condensation polymerization. So this one's slightly different in a sense that we still have the monomers, but in order to join my let me backtrack. We still have the monomers, but the problem is now that these monomers are not alkene base. So we need to figure out a different way to remove stuff from the molecule to join it together. What we're going to be removing from the molecule to join them together is water. It's simple reaction there. And in fact, I think we saw some of this water removal when we were making, I can't remember which function of it now off the top of my head. It'll come to me. So, I think we probably actually did it with esters and amides, when I think of it. So with this, the monomer needs to have specific functional groups. So for example, I need to have a carboxylic acid with an alcohol, or I can have a carboxylic acid with an amine in order to make these polymers. You could also use an acid chloride as well, but we don't tend to see that as often. If I was doing an acid chloride, what I would have as my simple molecule byproduct will be hydrochloric acid. And actually you might see that. I'll point out some examples of that. Now for this to work, the functional group needs to be on the N carbons because we're going to be adding those monomers together. And like I said, there's multiple different ways we can make it. And again, with different types of molecules. So you can either have one molecule that's repeated and has both functional groups, the carboxylic acid and an alcohol component. Or you could have two monomers, and both of those monomers have a di function group that's the same. So like dicarboxylic acid or a diol, and then you're going to see an alternation. I'll do these as examples so you guys can see the difference between those two. So like I said, carboxylic and alcohol or carboxylic and amine. With the carboxylic and alcohol, that's going to form our esters and make the polyester. With the carboxylic acid and the amine, that's going to form our amides. So we'll do the amides later. We'll just focus on the polyesters today. So like I said, with the examples, polyesters, polyamides, and those polyamides are really important because that's what's going to be our long amino acid chain that's going to then fold into the proteins. So there's a little biology link there. All right, so when we are forming polyesters as our first example, we are taking that carboxylic acid. You could also take an acid chloride, that would work as well, and you're mixing it with the alcohol and you're forming an ester. The difference with the ester in this case is that that's going to be repeated multiple times. So basically the link to them is going to be that ester component. Very often on these questions, they will ask you to circle the ester link. So just keep that in mind. That's why I wanted to do that as the do now, so you guys know how to identify the ester in a polyester. They also often ask you to identify the amide in a polyamide. So let's look at two exam questions so you guys can show it to you guys in both ways. I might need to restart my document camera. What are they doing out there?
They're doing Looney Tunes screens out there.
Make sure I end the right one. All right. And don't worry, we'll scan all of these and put it online. Okay. So there are two examples that I've taken that I want us to look at. This first example is with one monomer that's repeating, and this second example has two monomers that are going to alternate. So in the addition polymerization, we just had the one monomer that we were repeating multiple times, and that's what the first one's going to be very similar to. I want to point them both out because I've seen both versions asked. So you do need to be able to identify them and also break them apart later. But we'll worry about breaking them apart in our next lesson. All right. So in this case, when we look at this monomer, we notice that there isn't the alkene present. So there's not that double bond that's going to be broken and then going to be adding the molecule. So instead, I have two functional groups. I have the carboxylic acid component and I have the alcohol component. So what's going to happen is we are going to remove items from that molecule to start linking it together. So I'm going to use the same sort of structure that I did before. I'm going to draw the monomer so that way I can link it together. And again, they will specify how many repeats they want. So in this case, it's 3 repeats. So all I'm going to do to start off with is I'm going to draw my molecule. That's a monomer. So that's my first one. I'll draw my second one next to it. And I'm just going to repeat that again. Just be mindful, if you guys are using pencil on the exam to set it up, make sure you trace over it in pen when you have your final answer and erase the pencil so you can still get it remarked if you want that. Because any pencil or twink even, we won't accept it. All right, so all I'm doing right now is drawing the repeats of the monomers so then I can see how to put it together. Are we okay with that so far? All right. So in order to join these 3 monomers together, what I'm going to be removing is water to make the bridge between the two. So it's just like you were making a normal ester. For the carboxylic acid, we're losing the OH component. And for the alcohol section, we are losing the hydrogen component. So when these two exit, you get the H2O. And that's why we call it a condensation reaction, because water is going to be the byproduct. The other term that you can hear it being referred to is a dehydration, because it's dehydrating the molecule. All right. So if I remove those 2 components there, I'm just going to erase it so we can see how it links together. I would have the C double bond O and then the individual oxygen. Now that's going to result in a very long line right now. So hopefully you guys will be able to set it up a lot neater, but I'm just showing you what it looks like as a general format. Cool? Exact same thing for the next one. I'm repeating. I'm taking away this OH. I'm taking away the hydrogen. Water's coming out again. And then we can erase those 2 things because we've lost that in the molecule and just join them together. I need to clean up the ends because we're talking about a polymer. So right now it's not a polymer. So on this side here, we are losing the hydrogen. You can either, like I said, use a squiggly line, use the dots, use the square brackets. All of them will be fine. I personally like the square brackets. I like to write the N to refer to repeated. On this side here, we are going to be removing... Oh, sorry. We should be removing the H on this side and the OH from that side. Once the lagging catches up. All right, are we okay with that? So you can see how it's a condensation polymerization. It's a little bit more complicated because it's not simply just breaking the double bond and adding things together. In this case, I need to think about removing stuff from the molecule. All right, shall I show you another example that's a little bit different? Okay. This case, we are dealing with 2 monomers, and we're doing 2 repeated chains. So we need to show how it's repeating. So basically, if it says 2 repeated chains and I have 2 monomers, I should be drawing 4. So In this example here, these two monomers are different. We have a diol, so it has alcohols on both ends. And in this case over here, we have a carboxylic acid on both ends. Are we good so far? So, same sort of setup that we're going to do. We will do our CH2. The bracket with the 6 is just telling us it's 6 carbons long, but to help condense it down, we can just do the brackets instead of writing 6 carbons. So on each end of it, we'd have an OH. Then we draw the next monomer. So that's going to be the carboxylic acid. So C double bond O with our H. I'm going to try to draw them a little bit closer so we don't have that super long tail. And then we have a 4 repeating unit. And then we have another carboxylic acid. Are we good? All right. So we want 2 repeated units. So once again, I'm going to draw my alcohol. And I'm going to draw another carboxylic acid. Now, it's obviously a little bit big because I'm trying to draw all the monomers so I can see how to put it together. Once you guys get better at it, you won't need to do this. And that should be OH. Forgot the oxygens in those guys. Small little typo we need to fix. They're going to be a little bit squished together. That's okay. All right. Are we okay with that so far? So the blue ones are my alcohols. The red ones are my carboxylic acids. The next thing I need to do is remove the water again. So again, hydrogen comes off the alcohol. OH comes off the carboxylic acid. So this is what's going to be removed to make the water. And then that's going to be joined together. Again, look at the next one. This one's going to lose the OH. That's going to lose the hydrogen. That's going to come together. Next one. Hydrogen, OH, comes together, loses the water. Oh, sorry, let me move that up so you can guys see it. You don't need to write down that it's obvious losing the water. I'm just showing you where everything's going. This side over here, just remove the hydrogen, put the square bracket around it. This side over here, oh, let me put a little dash to make sure it's continuing. You lose the OH, put the square bracket, N. So 2 repeating units of it. The thing you'll notice that's different between this polymer and the one before is you see how it has the 2 oxygens and then the 2 carbonyls and then the 2 single oxygens and then the 2 carbonyls. So that tells you have 2 monomers making that polymer. In this example, you see how you have the single bonded oxygen and then the double bonded oxygen, single, double, single, double. So it alternates back and forth. In this case, you get the doubling and then the alternate, doubling and then the alternate. Does that make sense? And that's how you can identify if you have 1 monomer or 2. All right. What questions do you guys have? Nothing? Makes sense? All right. So I want to see what you, should I leave it up for another moment? See, some people are still writing. All right, so we have about 25 minutes left in class, and I want to see what you guys would prefer to do. I know I've been doing quite a bit of talking. There is the crash course video that we can watch. There's also some Mahi Choice if you guys want to practice it. So what would you guys prefer? Do you just want some time to practice, or do you want to watch the video? You can always watch the video on your own time. It just helps reinforce what we've talked about today. You want to watch the video? Okay. Cool. So I will pause the recording so that way it doesn't make a weird video on there. And we can watch the crash course. All right, can I move this now? Okay. It is going to all be scanned. All All right, just be mindful, he talks very fast.
Here's that one.
I just want to make a note that he's obviously going into things in more detail that you guys would need to write up or explain on the exam. Say, for example, the naming process. You don't really have to worry about it. I haven't seen it come up in a level 3 exam. But it's just a good kind of recap, and it's a good kind of real-life application when we're thinking about these polymers. So you have just over 10 minutes left. I think you can get a little bit of work done, especially that SciPad page if you guys want. So with the Mahi Choice, I've differentiated the different tasks. It does get a little bit harder. If you find you are struggling with this material, I would suggest it's probably worthwhile to go back to lesson 11 and do the notes on esters because it's similar reactions. But yeah, there's SciPad work, there's ESA stuff as well, and if you're feeling like you're really confident with this material, there's the collated questions from No Brain Too Small. They're all from the past NCA exams, and you guys, like I said, have covered most of the organic chemistry, so you can do most of these collated questions. Keep in mind when you're thinking about collated questions, what type of question you are struggling with, so that way you can target that specific one. I'm always happy to look at stuff, so even though I might not specifically assign something, if you do a past exam question and you want to show me it as evidence or you want some feedback, actually probably both, please let me know. So I'll leave that up. You guys can get a little bit of work done. I'll have a little wander around and let me know what you guys get done, so I can give you a sticker and give you some feedback and some credit for that evidence. Did you throw the lolly and chase after it? That's so mean. All right, so just to recap today, we talked about the 2 different types of polymers. That was the addition and condensation. We looked specifically at polyesters. Great work today. You guys on polyphenes. You guys have made it to 30 minutes of streaming. Do you still want to keep collecting? Yes. Because there's still the option for baking and moving. Keep collecting? Keep collecting? Okay. Thanks, man. See ya. Keep working and doing the Mahi Choice. Remember to comment on things or send me an email. I'll try to get a look at it.